How to make copper carbonate at home. How to make copper carbonate at home.
I have
Copper,
I have
vinegar, copper acetate,
I have a pen. I have
sodium carbonate, copper carbonate,
apple pen.
hydrochloric acid.
Pen pineapple apple pen.
Warning: always wear gloves during this experiment. Don't be like me. We are handling corrosive acid and copper salts, which when ingested will become a hassle. I have here a bottle of white vinegar, the one without sugar, which is actually dilute acetic acid. To the dilute acetic acid, I poured in some hydrogen peroxide, which I bought it from my local pharmacy, producing a pure acetic acid which is quite corrosive. I have here many copper wires. Because I live in somewhere, I actually need to go to the trouble to pull out the copper from the wire sleeves, as shown here. So now, I will add the copper wire into the solution and let us see what happens. As you can see, the blue color of copper 2 ions starts to form. This is because copper will dissolve in acetic acid, producing copper acetate. The hydrogen peroxide just increased the rate of reaction. I will explain it in another video. I will add more vinegar to dissolve more copper. Then I stir the solution with my glass rod. Here is a close-up shot of the solution. Wow! Within a minute, the whole solution has become blue in color. Here is a time lapse of the reaction. You will see bubbles forming. This is because hydrogen peroxide oxidizes the copper, which then react with acetic acid to form copper acetate. As hydrogen peroxide decomposes, it releases oxygen gas. You notice when I add in more hydrogen peroxide, more bubbles is formed. You will also notice that the rate of reaction increases at first, then when the concentration of acetic acid decreases with time, the rate of reaction also decreases, thus producing less bubbles. Now, I am going to filter the copper wires out from my solution using tissue paper and funnel. Oops, the funnel fell, but not to be worried. Take a look at the copper wires after the reaction. Here is a picture of the filtrate. The blue color is so intense and beautiful. That's why I love chemistry. Now I am going to prepare a sodium carbonate solution. Sorry, because I didn't have a measuring balance at that time, so all the concentrations of the solution is not correct. I just eyeballed it. One more thing, please do not add water to the solutes. Always add the solutes to the water, and not like me. As sodium carbonate dissolves in water, it releases heat, so when the water first contacts the sodium carbonate, the heat release might boil the water, spurting hot alkali solution everywhere, and we don't want that to happen. So just bear it in your mind. At first the solution will seem cloudy. That is normal. It will eventually become clear. Now this is where things get exciting. On your left is the sodium carbonate solution, and on your right is the copper acetate solution. I will now mix the two together by pouring the sodium carbonate solution into the copper acetate solution. The bubbles you see here is because my sodium carbonate is not pure. I actually made it myself in my previous video. Not all the sodium bicarbonate is decomposed, so bubbles will still form. If you want to check out my previous video on how to make sodium carbonate at home, there's a card above. You can see I quickly prepare a more concentrated sodium carbonate solution as I observed that not much copper carbonate is formed. Indeed, after that, more copper carbonate precipitate is formed with lots of foaming. I then mix everything with my glass rod to make sure all the copper acetate has been reacted. Then I let the heavier copper carbonate settle down for a few hours. While waiting for that to settle, I noticed that the tissue paper I used to filter the copper acetate solution has interesting patterns on it. It really looks like Lichtenberg figures. Very fascinating. But it is not Lichtenberg figures. I already decant the liquids above my copper carbonate so I can filter out the copper carbonate from the remaining liquids. I wash the copper carbonate with distilled water to minimize loss and dissolve away any other unwanted substances. Look! Liquid coming out is clear, indicating that no copper carbonate is passing through the tissue paper. Here's a top view of the copper carbonate. Then take the tissue out and put it somewhere to dry off through evaporation. It should look like this when dry, forming a powder. Thanks for watching. Hope you made it this far into the video. And I will see you next time.